thought we should get into the who, what, when, where, and why before we get into the how. This is primarily aimed at people with milling equipment in their shop or home. Most people would probably just buy one of these torque plates. It's not exactly an extremely expensive item, and chances are it's not necessarily worth your time to make one instead of buying one. A torque plate is used to correct for the distortion of the cylinder caused by torquing the head down. It basically emulates the head, or at least the forces that the head would put on the block. As you can see here, torquing an item torquing the head or a torque plate down onto the engine block does cause some maybe not significant deformation, but enough that the ring seal would be affected. Here I'm just checking the tool offset, making sure that the machine is where it says it is. I hadn't proven this program yet, so I was a little bit paranoid about it. This is a .625 gauge pin that I'm checking in the holes. I have the first piece up against a table stop so that I can locate the second piece of stock in the same position. The material I'm using for these was just some soft jaw material I had lying around, 3/4 and 1 inch. This spacing operation worried me a little bit. The spindle slowed down significantly, so I went to check on it, but didn't end up changing anything. Here I'm just checking the fit of the pin in the second piece. This setup is 2.625 pins through the holes that we drilled in the previous op. laid on top of the vise. This gives a fairly accurate reference angle without having to buy angle blocks. I like to deburr with a small stone. It leaves a sharp angle that won't cut you. Here are the final pieces. The surface finish could have been better, but for what they are, it'll be perfectly serviceable.
This is the tool I'll be using for most of the roughing. This is a Niagara 4-flute roughing end mill, 3/4 inch. We'll be running it at 2250 RPM, half an inch passes, pretty wide width of cut. The only downside to this guy is it chip welds pretty bad if you don't get all the chips out of the way. A little bit of WD-40 and a shop vac should fix most of that.
I'm making this out of 3-inch thick Mike 6 cast tool and plate. It's quite gummy. I'm center drilling with a number 21 center drill. I know I should be using a spot drill, but I don't own one yet, so. This half-inch drill behaved wonderfully in this gummy material. A little touch-up with a stone before using it really helped.
The 5/8 drill didn't quite perform as I had hoped. It chattered pretty badly, but my drilling setup isn't the greatest anyway.
This roughing end mill isn't center cutting, so I have to ramp it quite a shallow angle. Here I believe it's 1 degree. I'm just using a 4-flute HSS end mill to clean up these holes.
I made a little mistake here flipping the part over for these corners. I wanted to use a 1.5 inch length of cut carbide end mill to get these corners done, and thought it would be okay to just set this part up against a stop, but I forgot to deburr after doing this chamfer here, and the burr shifted the part over quite a bit, probably, I don't know, 3/4 thousandths, if not a little bit more. So I'm going to use a longer end mill, same length of cut, but it'll be able to take it all from one side. This will hopefully clean up pretty nice, but I won't get this corner radius that I wanted. It's going from 20 millimeters to 25. Here's the finished torque plate on top of a Z20 head off of an EJ20X. You can see that the chambers line up just right, as do the bolt holes on this Velcro gasket. Should work a treat.